Thanks, guys. The last time that I was in this neck of the woods was about 20 years ago. I went to a town called Meadville. You guys know where that is? Isn't that the tooling capital, or there was a title for it at the time?
Capital.
That's what it was. But I got in trouble there,
Tool
so
City,
they
USA.
never let me back. So, how many students are here? First-time students? Okay, quite a few of you. I get this question asked a lot. First of all, my name is Wyatt Swain. I'm a welding engineer by trade, and I got into it by accident. And when I say that, I've always loved welding. I got started welding very much like a lot of you do. You do a project in the house, and I was in high school, and I got fairly good at doing that stick welding, until I did vertical up, and that was a little tougher. When I went overhead, that's when my life changed, because how many of you welded stick overhead? Okay, so you recognize the sound or the sizzle as some of that goes into your ear canal. As soon as I heard that the first time, it was so horrifying, I decided to get into a totally different profession of welding. And that's where TIG welding came into play. But here's how the story goes. I get asked how I really did get into it, and I can attribute it to my mother-in-law. How many people can say that their career was developed because of their mother-in-law? Well, what had happened is I had gone to a little college in Kansas, and this college was a great college. It was hands-on. In the morning you had welding classes, in the evening you had engineering classes. And a great combination. It was only a 2-year program. And after 2 years, I got married. And my mother-in-law was at my house so often that I moved. I was in a little town just outside of Wichita, Kansas, and I moved because I was sick of her. I was just absolutely sick of her. Now, I wanted my career to be in welding. I just didn't know exactly what I wanted to do. So I already had the hands-on skills, and I moved to California. Going from a little farm town in Kansas to California was quite a change. So I get there, I've got a wife and I've got a little boy, and I needed a job. So I opened up the newspaper, and there was an ad, and it said, "Welders Wanted." Wow, this is great. So I go to this place that's called Campbell's Shipyard. Anybody ever go to a shipyard? Yeah. It's a pretty rough environment. And so I go in, and I'm filling out this application. There's a guy next to me that looks like Popeye. And he's got the tattoos, and he's gruff. And he's watching me fill out this application. He says, "Son, do you know how to weld aluminum?" I said, "Well, yes, sir, I do." He said, "What about stainless?" "Well, yeah, I do." "Do you do that heliarc type welding, real thin stuff?" I said, "I love it." He says, "You don't want to be here." You don't want to be here. He says, over 50% of the people in this particular shipyard are ex-cons. This is a rehab area, and we teach them how to weld. I said, "Okay, so what should I do?" He says, I got a place I'd like for you to go." And he opens up this book, and he rips out the page, he points at it, and he says, "Go to this company right here." And I took it from him, and I went to that company, and I got a job. Little did I know that it was on the space shuttle program. So my career got started because of my mother-in-law, and I appreciate her for it. So I got started in aerospace, and it just continued from there. I got into electron beam welding, got into titanium, pretty high levels. Anybody ever hear of Skunk Works? It's
SR-71.
SR-71. It's where you build an aircraft. It's top secret. You build it in about 2 years. Now, most aircraft, secret aircraft, take about 20 years to develop, but this is the shortcut. So that's what I did. And I accidentally came across a company called Link Electric. Guy came into my office and said, I would like to hire you as a consultant. I said, "To do what?" "Link Electric, my God, you're the largest welding company in the world. What do you need help in?" And they said, "Aerospace. We don't have a lot of strength in aerospace. So that's how my involvement got associated with Lincoln Electric. And part of the contribution that I bring to Lincoln is I represent you, the welder, and that's what they want. Now, who wants to go into a meeting and have the president come in and say, this is how we're going to build things and this is how it's going to be done? Well, Marty has to say yes, because that's where he gets his paycheck. But at the end of the meeting, they come to me and say, well, why? What do you think? And I would just say, hey, look, I don't like it. They go, well, wait a minute. What do you mean you don't like it? Look, you're trying to weld aerospace, and it's not like welding half-inch thick material. You've got to weld knife edges. You've got to weld on the edge here, and you don't have a machine that'll do it. Well, they didn't want to hear that. So they said, we'd like to sign you up to a contract. So I've been battling with Lincoln Electric since 1986. And it's a love-hate relationship. I'm the welder, they're the manufacturer. And that's a sweet way to have it. Wouldn't have it any other way. So I got into a couple of the programs that Lincoln has, and it's motorsports. They said, how would you like to go to the Indy 500 and be the trackside welder? Okay, I guess I could do that. How'd you like to get involved in NASCAR? Oh darn, I don't know, let me think about it for a while. Okay, I can do that. Well, in 2003, I sold my aerospace company, and then I started doing almost full-time, and I say almost full-time for Lincoln Electric, mostly motorsports. So, got heavily involved, and I want to share with you today a couple of crashes that we've had. And it's kind of interesting how crashes occur and how the different independent NHRA, anybody here NHRA? How they respond to it. And usually they don't respond the correct way because they just don't know. They have a crash. How do you know what caused it? So I want to start off and I want to describe who's using 4130 Chrome Moly material. Anybody use 4130 here? Very popular. It's a tubing that's been around for years and years and years and years. And all you have to do is weld it with the right fillers and the right techniques and the right gas, and everything is fine. So sometimes you hear it called Chrome Moly, 4130 Chrome Moly. There's all kinds of abbreviations for it. But I just want to show you a few people that are using it right now as we speak. Okay, now this particular car is a funny car. It has the same engine, 10,000 horsepower, but it's shorter. Now this car rarely has a problem because it is shorter and it takes the torques and the loads and everything else. But before we go into the next slide, I need for you to show me something that happened back in 2006. Now this happened to be a guy, his name is Cory Mac, and he was driving this top fuel dragster, the long one, and he had a failure. And I want to see if you can recognize where the failure took place, because this is all part of this class. You have to pass this test, okay? There's only going to be a couple questions on it. So, Cory Mac called me. He said he had a bad crash, and you'll see it in a minute. But he said it's really strange. The tires have a tendency to blow in these cars. They're running at 9,500 RPM. So when a tire blows and it just gets a little bit of rubber slapping, we've lost drivers because of that. So now what happens is almost every car that has a crash, they blame it on the tire. Now watch this. Oh my. 300 miles an hour, and he has this type of a crash. Now that you know that he called me and he said that he felt his butt dragging on this crash, look real close at the bottom of the car. Something is dragging there. You see it? Now look at Cory. He's up here. He's almost at 300 miles an hour. Ooh. That's not a good day. And they'll show you one more time, I think. These are only like little 2-minute.
It is a good day he survived.
He did, and it was unbelievable. His sense of humor right after that was as normal. I think I'd pack it in about that. What do you think, Marty?
Yeah, oh yeah.
Basically, the ring, the spiral,
You don't need sound for this. I just want to show you how we get involved as welding metallurgists and trying to define what happened. Because we're going to show you what we do as metallurgists to show the world what happened. Now, this leads up to a crash. I got to tell you about 2004, St. Louis. There was a guy by the name of Darrell Russell, and Darrell died in his run, and he had a tire blow, and the explanation was that it was just what happens in racing. It happens. He blew a tire, and it was blown off. There was no longer a safety issue until this crash came up. Now we're 2006. Still, nothing was done because nobody knew to do anything. Now, we know that there's a problem here. Because the frame is so long, we know that it may snap, it may twist, all kinds of crazy things can happen. But in 2007, and we just keep going up in the years, still nothing has happened. In 2007, I got a phone call from a guy by the name of Don Schumacher Racing. And Don called me, I was at the racetrack, and he says, I got your number, I don't know who you are, but I need to ask you about welding 4130 Chrome Moly. He says, I've on a race team for years, we're having trouble weld repairing our race cars. Never had that problem before. He says, is there anything that you can do to shed some light on it? I said, sir, 4130 is very repairable. He goes, well, that's what I thought, but I just wanted to talk to you. And I didn't have any other point of reference for him. And then what happened in 2007, in March of 2007, there was a guy by the name of Eric Medlin that was at the racetrack, and it was after the Gator Nationals. Now, when I say after, what happens is they do practice runs after everything is done the following Monday morning. And they're tuning and they're testing and they're doing all kinds of crazy things. And Eric, he didn't have the cameras watching him. He didn't have anything. All he had was his mechanic with him. And he took off from the line, and his left tire blew. And the left tire started slapping the cage, and the cycle of 9,500 RPMs shook his brain, and he died. It required an investigation. This guy is the godson of John Force. Now remember that date, 2007, March. Fast forward to, I want to say it had been later in the summer, almost near the end of the season, there was a guy by the name of John Force. Got into the same crash. He had a funny car, same type of funny car, same type of engine, same everything. Now we're starting to see a pattern. So John Force takes off from the line, and we're going to show you what happened here. And I want you to watch it very closely, because when he gets to the finish line, watch the camera and how it zooms in on the car. And just so you know, John Force isn't with the car. So he crosses over, he hits Kenny Bernstein. Had a bad day there. The safety team chases the car, and
I remember that race.
yeah. Okay, so the safety team, he gets there very quickly. He's not in the car. So let's watch it again. Watch what happens to the back half of the car, because the camera guys don't even catch it. So he hits 315 miles an hour. He hits a button. We have two parachutes that come out. They don't come out at the same time. They're offset purposely. So they come out, and the G-force, the reverse G's, is so much that the car splits in half. He stays with the parachute and the two back wheels. So he stayed with the parachute. He came down, his knees were dangling over the frame. When he came down on his kneecaps. Hands and knees. He had leather gloves, which did very little. He had a broken ankle, it scraped off his kneecaps. He was in bad shape. And it was kind of crazy because what happens in a crash like that, it goes through a full investigation. And believe it or not, they're insured. These guys are insured. So the insurance company comes in and says, don't touch this car, leave it alone. We're going to find out, we're going to get to the bottom of this because we're having to pay out all these big dollars. And they investigated for about 3 months. They came up with nothing, zero. It's racing. Tire blew, same excuse that you hear all along. All along it's been the tire. Until John Forrest called us directly. He was in the hospital. He was no longer in a coma, he was in pain, but every once in a while he'd hit the button, and I think morphine would go in and he'd laugh a little bit. So he called us, he says, hey, you guys still up for the investigation on this? We said, yeah. Well, he says, I'm mad as hell. He said, I lost my godson, I damn near lost my own life. So is there anything that you can do to see if you can diagnose what the problem is? I said, we'll give it a try. So we went over to his shop, Brownsburg, Indiana. Upstairs, he had this frame. And the insurance company had already checked it out, did everything they were going to do, and said, here, it's yours, do what you want with it. So we went to a high-stress area, and we cut out a section. And I want to share that with you today, because you're going to see what I saw. And in the beginning, you're going to say, I really don't see anything. But at the end, you will. So if I could come over here. IndyCar uses 4130 Chrome Moly. Keep going, next. You know, these guys, that's the bad guy. They're starting to use 4130 Chrome Moly. It took many years. Go ahead to the next one. Experimental aircraft, they use 4130. And go ahead to the next one. Okay, I'm going to stop here for a minute. We're going to go back this in a minute. This guy right here built his own powered parachute. He won the long distance contest. Now, this particular parachute is a strap-on. Put it on your back. It's about 28 horsepower, and he's got hand controls. He's got a parachute on the ground, and he takes off running, and he's increasing the horsepower or the prop speed on his back. By the time he hits to step number 6, he's airborne. So he runs like crazy, and then boom, he's up. He's up and over the trees and going. This runs at 26 miles an hour. Not very fast. Can't get any more out of it. 26 miles an hour. I happen to know I own one. But this is crazy. If you build your own, boy, you better make sure you welded it correctly. So the guy's sitting there with this little dinky trophy and the biggest smile on his face. He said, I won the long distance contest. I said, from where? No, this was Oshkosh, Wisconsin. 800,000 people go through there. And he won the long distance contest for powered parachutes, meaning he left his house and he went further than anybody else. I said, where do you live? He said, Chattanooga, Tennessee. 700 and some odd miles. Chattanooga, Tennessee, 26 miles an hour. Now what happens if you get a 30-mile-an-hour headwind? You're going to Florida. So I said, you know what, I got to ask you, how did you plan this? And he says, it wasn't hard. He says he just follows the highways. He had a little map that he strapped to his wrist. Everything's sun control. The maximum fuel capacity you can have for what they call Part 103 means you don't have to have a license, period. You can buy it and go. He says 5 gallons will last me about 2.5 hours. Okay, you can do the math. You can do the math. So you go, okay, so you have to land every 80 or 90 miles. He goes, yeah, that's true. I said, so where do you land? I see somebody's here with you. Is this your wife? He goes, yeah, she's a chase vehicle, but she's just there. She just doesn't want to fly. I said, you keep extra fuel in the van? He goes, no, I just land. There's a gas station, I just land. Can you imagine that? You're following an interstate and you see, Mobil. You just land in the parking lot. Fill it up, 5 gallons, here's your money, and he takes off running. 6 steps, he's off and running. I said, okay, now, how much food do you prepare? Does your wife have a cooler there and all? No, I see the Golden Arches, land. Hotel, land, not a problem. Took him 2.5 weeks. So I put this in the program, and I keep sharing it because I've just never seen anything quite like it. In all the adventures that I've had, this one's interesting. Now, there was one little thing that he mentioned. 2.5 hours in the air, you gotta ask the question, do you ever have to go to the bathroom? He goes, well, yeah. And before I could ask, he goes, and the answer is yes. I go, okay, just wondering. He says there is only one hazard that he had in the flying, other than weather. Lightning's a problem, wind, rain, all that. He says, but what was happening was he was following the interstate. He was causing collisions. Hey, Martha, did you see that? The guy driving to the center, of the highway. And so he had to kind of offset the highway so he didn't cause problems. But anyway, I've kept that in the program. It's just that good. Yeah. Okay, now this is really getting to the crux of metallurgy and what things are all about. And we're going to talk about this alloy only. Right here. There's a couple of other samples, and metallurgically we test them out, and we don't give them a stamp of approval until they've gone through, I can't tell you how many thousands of hours of testing. These other 2 alloys, everybody's trying to knock off number 1. 4130 still is number 1. Now, what makes it so valuable? And this is on your test, just so you know. 4130 Chrome Moly has got high strength. So why did you buy 4130 instead of mild steel? They look the same, they smell the same, they weld almost the same, but one's stronger. So why would you spend twice the amount of money on 4130 as mild steel? Any idea?
Lighter. I'm going to use less to get more.
You can use less. You can buy thinner wall material, and your car is lighter, your aircraft is lighter. So it's strength to weight ratio. So if you want to improve anything in racing, you go lighter. And the only way you can do it is to take a look at the metallurgy. And we're going to show you what that is. They hear about it all the time, but this is really what 4130 is all about. It has a carbon content that is somewhere around 30 points of carbon. Doesn't mean much to you yet, but it will. It has a few elements in it that are pretty normal. And see the CR right here? That's chromium. So if you hear the term Chrome Moly, it's not like it's got a lot of chrome in it. It's got 1% chrome. And it's got, look at this, moly. 1/4% moly in it. But when you take all those ingredients and you put them all together, you get some pretty good properties. So let's go ahead and show the next slide. Here's the properties that you get. You get tensile strength and you get yield strength. Now, I want to show you what the difference is. Tensile strength, remember that 95 KSI, 1,000 pounds per square inch. If you put this on a machine and clamp onto the material and pull it, that's what it'll measure. Now, this material will actually start to give up the ghost before that. It'll start to stretch, and it'll get plastic. It'll stretch and stretch and stretch. When you see it stretching, it's at 75,000 pounds per square inch. 75, and it's pulling, and then boom, it'll quit. It'll give up, it'll break. And that's your elongation. So this material has about 12% elongation, whereas a rubber band, 12% of that strength. So it's not just going to snap, it's going to move, and then snap. And that's important. We're talking about NHRA. What happens when they drop the clutch? They need something. They need to be able to flex. They can't have it rigid. If they have it rigid, it's going to go boom, just like that. So just know, this is a condition called in condition. So 4130 in the in condition. So we bought that because we want high strength, lightweight. So go ahead to the next one. Okay, now let's take a look at tubing, mild steel. You can go down to any metal mart and buy this. 1018. The only thing that's in it is a little bit of carbon, 18 points of carbon. These are all just elements that are there for the processing of steel. That's it. So let's see what the properties are. So what did we say 4130 was? What's this?
75.
95 versus this right here, 55. So you can reduce the wall thickness considerably. You can almost cut out, I'd say roughly about 30 to 40% of your weight just by going to 4130. Just like that. And now you got a fast car. Now this right here, the reason it's so attractive, notice this right here, 40%. What does that mean to you and I? That means that you can take this tubing, mild steel, and you can bend it, you can do all kinds of things. But is it strong? No, not very strong at all. And unfortunately what happens is a lot of roll cages get made of this. And it's a false sense of security, because what happens is as soon as the car rolls, it snaps off the cage. It doesn't have the strength. It looks good. It was easy to bend. That should tell you something. If it was easy, don't do it. Go ahead, next one. Okay, now we're going to get into a crash analysis. When we cut a section out of this car, this is what it looked like. This is tubing, and you're going to see clusters of tubing. You're going to see a main frame, and you're going to see tubes coming in at different angles. So that's what we did. We cut into a couple of different tubes. And our whole objective, first of all, is just to look at it. And if you look right here, you'll see a weld. You know, what we're trying to do is we're trying to eliminate the welder right off the bat, the person that welded that. Is this a good welder or a bad weld? So there are not a lot of characteristics that look bad on this. In fact, this sharp edge right here, turns out that broke in a heat affected zone. And that's the weakest part of a weld. And that's where it's supposed to break. That's not going to change. You're going to weld it that way, I'm going to weld it that way. That's where it's going to break, the heat affected zone. And that's where the liquid line goes down to the metal. Very normal, think nothing of it if it breaks there. You've got it under design if it's breaking. So take a look at this. I don't see anything wild and crazy. I looked right here. Nothing I could really jump up and down and say, yeah, that looks terrible, or that's a problem. So, you know, we looked at the end view, still nothing unusual. Now, the beauty of having a lab is we have a spectroanalysis machine, scanning electron microscope. We're talking millions of dollars for these things. And I have them at my disposal, so it's kind of fun. Okay, so let's take a look. This is a weld. You can see a tube came into a tube. And this weld right here, kind of a triangular shape, there is absolutely nothing unusual about that. The grain that you get out of a weld is kind of a mosaic pattern. So if you look at that, you can see that this grain is pretty consistent in size. Nothing terribly unusual. I looked at that area right here. You look for a sharp notch, a line. Maybe it didn't wash out correctly. Maybe the guy didn't add filler correctly. I didn't see that. Now I moved over to this side, and you can see it didn't penetrate all the way through, but it didn't matter. It held up, meaning that the weld was good, and even though it's a little bit dished out, it's very smooth. The transition is smooth, no sharpness at all. So the nugget size was large enough that the failure didn't happen there. So again, we're looking at this thinking, there's got to be a smoking gun here. Something is wrong. And if you look real close, I don't know if you can see it. This kind of gave me a trigger. Take a look right here. There was a color change there. And I thought, you know, it's got kind of a white spot to it, but I couldn't tell exactly what was going on until I started looking a little bit closer. You see a shade difference here, a shade difference here. Then I started noticing Well, there's something weird right here. I don't know what that is, but it is weird, it is different. So then I decided to blow it up to about, I don't know, 200 power. And that's the next one. And there is the smoking gun. Here's the problem. Anytime you have a high-performance vehicle of any kind designed and developed, there's very little margin for error. And when I say that, if you're developing something like an NHRA dragster, the margin of error is about 20%. So you design this, you don't want it as heavy as a tank because you want to go 315 miles an hour. So you got a 20% margin in there. Now what happens if you screw up the metallurgy? You're already right on the edge, right on the edge. And something, I don't know if you can see this crust right here. This crust right here. It's kind of hard to see, but see the roughness here? It's called a decarb layer. And that decarb has no strength whatsoever. In fact, you have to deduct that from your design, from the strength of the material. We're already on the edge, and whatever process caused this, this is something that was caused by heat. Don't know what caused it. Don't know if it was an oven. Don't know if it was a rosebud that a guy sat on there and laid on it too long. But that can happen. You had a question on it?
Is that like a natural phenomenon of case hardening?
Very much like case hardening, yeah. What it is that you're exposing this material at a hot temperature and letting oxygen attack it. And when it does, it's decarburized. There is nothing there in value. So not only is there nothing there in value, but this material right here, it's got cracks that are already propagating. So all you need to do is do something phenomenal, and it's going to crack and it's going to break. So let's take a look at this. 2004, we had a problem. Not sure what it was. 2006, Cory certainly had a problem. Wasn't sure, but he couldn't agree with NHRA that it was a tire. And what he was claiming was that something in the frame broke. NHRA was saying, no, it was your tire. We got the cameras to prove it. Then we have the death with Eric Medlin. Same thing was claimed, that it was a tire that caused it, but there's no cameras to show it. And then all of a sudden, we get the big guy, John Force, and he crashes. And you know, the thing about it is, what if he'd have died? If he would have died, you don't have a John Force or somebody that mad to follow through with it. So what this caused was a chain reaction. And I can tell you this kind of put me on the hot spot. I went to this show called the PRI Show, Performance Racing. It was in Orlando, Florida. And I was summoned to come and visit the NHRA SFI committee. Anybody ever hear that? All these racing organizations, they have a little sideline organization that takes a responsibility. They don't take it themselves. They have a quality control group. And so this report ended up being about somewhere around 130, 140 pages. And it was handed to a guy by the name of John Medlin. Ever hear that? John is the dad of Eric Medlin, the kid that died. I said, John, do with it what you want. It's up to you. I didn't show these presentations until after Medlin said it was okay. So anyway, after this presentation, the whole group got together and said, certainly we've got a problem. You found what it was. What do we do next? And what happened next was a great thing. They redesigned the car. There used to be 2 rails running the car. There's now 3 rails in the main frame. The cars were only lasting 15 races, $80,000 a frame. They're lasting 15 races. They're now lasting 115 races. So you can see that it's going to be safe, and somebody's going to have this conversation 30 years from now, and the same thing's going to happen. Horsepower is going to go up, frame's going to be weak, there's going to be something that's going to cause a catastrophe, and they'll fix it. And that really is racing. It's sad, but it's the truth, and that's the way it happens. Okay, so there's a lot of considerations in design, and what I want to leave you with in this program right here is you are the designer. You're building something. You designed it. So you got to ask questions. How fast is this going? How safe is it? What wall thickness? You know, you just can't build something out of aluminum because it's light. You know, you don't build it out of 4130 just because you heard that it's good stuff. You got to get the right filler materials. And unfortunately, what's happening out there is that you go to your local weld supply house. Do we have anybody here? Any weld supply houses? And if you ask them what filler is it going to take to weld my 4130, they're going to hand you 4130, and you're going to weld, and it's going to crack. You go, well, how does that happen? It happens all the time. They're going to give you commercial grade 4130. It runs about $8 a pound. It's got a lot of trash elements in it. 4130 is crack sensitive. So we have recommendations. It's posted all over the website, the right filler to use. And I'll give it to you right now. You have about 3 choices, so it's not like you're stuck with one. But one of the criteria that we selected was this filler material has to be inexpensive. And I went to the air show, and there's a guy there saying, use this filler. It's the only one to use. You know, he was correct in that it's what's used in aerospace, and it runs $130 a pound. Now, is that practical? Is that what we want? And the answer is no. It makes no sense whatsoever. So we did the testing. We have numerous filler materials that we tested for this. The number one filler turns out to be a filler called ER80SD2, and it's about $8 a pound. When you finish your weld, I'm recommending to you that you leave it alone. Don't do any post-weld, heat treatments, stress reliefs, anything else. Use that undermatched carbon filler that I recommended and leave it as is. Now you saw what happens in NHRA when somebody decides to take a roast bed and heat it because his buddy told him to, and his grandpa taught him to do that. Now here's the one thing I really want to stress. When you're welding a part, I don't care what it is, we're just stuck on 4130 right now. When you fit it up very nicely, you don't have a lot of gaps. You don't have a lot of stress. So use the right filler and leave it alone. Now, if I ask you what the word heat treat means to you, what would you say? What does heat treat mean to you? You ever hear that term?
Doesn't it relieve the stress of a weld?
Okay, stress relief. Okay.
Changes the properties.
Hardening, okay.
Changes the properties.
Changes the properties, absolutely. All of these are correct answers. But you need to know that heat treatment, the term heat treatment is generic. It does change the properties. So the question is, what are you trying to do? What are you trying to do with your type of heat treatment? So I posed this question in Oshkosh. I watched a guy doing it. I said, what are you doing? He says, I'm stress relieving. Okay. I'd like to watch you stress relieve. How do you do it? So he takes a rosebud and he creates a figure-8 pattern. Apparently he's done this a lot because he looks like he's doing it very, very well. And I'm watching this whole zone get red. And I said, how hot do you get it? And he said, blood red. So blood red. Well, what is blood red? He says, well, he says, do this. Squeeze your thumb and look through your fingernail. And that's blood red. Okay, so you do that until it gets blood red, and then what? And then I stop. Okay. I decided that I was going to test that because I've got all the instrumentation in the world. And I've got all of Marty's bonus money, so I can use it on the pyrometers and everything else. So I set this up to do my own test. What is blood red? So I heat this thing up. I'm looking at blood red, but I've got little thermocouples set up all over the place, so I can really monitor this. And I go, okay, I'm there. And I hit 1600 degrees Fahrenheit. Okay, I'm gonna do it again, 2 or 3 times. And I hit a range. I hit 16, 15, 50. I even hit 1700 degrees. Now, do you know what it does to that material when you hit 1700 degrees? or even 1600 degrees. It heat treats, but it's called anneal. Annealing is softening. Okay, so here's my one question. You have to pass the exam. Who's the students? Raise your hands. Okay, to pass the final exam, here's the question. Why did you buy 4130 over steel? Strength to weight ratio. So why on earth do you see these guys annealing and softening it? They just turned it to mild steel. So you passed the test.